Hello students, I welcome you for this particular session on Fanuc turning. So in this particular session, I'll be covering three exercises based on Fanuc turning. So as you know, this sim and automation lab consists of two uh, modules or two parts. One part is based on Mastercam milling and Mastercam turning, and second part is mainly based upon the Fanuc turning or the Fanuc lathe and Fanuc milling. So in this particular session, I'll be covering Fanuc lathe exercises. So in this particular exercises, what you're going to do, so there's a bar of diameter 32. So diameter of this is 32 mm and length of the given job is 100 mm. 100 mm. So what you're going to do, you need to turn, that is you need to remove the material of the given shaft such that the diameter at the right end should be turned to, so this diameter should be 25 mm, and the length of the turning, that is this length, has to be 30 mm. Okay, so this is the job given. You can see here 40 mm. I am going to say this should be 40 mm. So this has to be, so this material you need to remove by using turning operation. So you can see this is the job given. So the job size is 100 mm length and 32 mm diameter shaft, and you need to turn that given shaft to a diameter of 25 mm for a length of 40 mm. Always remember in Fanuc lathe, the axis system that we use is XZ, where X indicates the diameter of the job, Z indicates the turning length of the job. So always remember, before starting with any of the turning job, you need to first locate the origin of the job, and always the origin is located at the extreme right end at the center of the right face, that is as indicated or as shown in the figure. So you can, this point, that is 0 comma 0, is the origin of the given job. So what are the operations that are based in this particular job are, first you need to do the facing, and then you need to turn uh, for a length of 40 mm, such that you will reduce the 32 mm diameter to a 25 mm diameter. So for this particular job to be done, or the program to be written in the Fanuc Lathe Denford software, you should know all the G codes and M codes. So I am assuming that you are familiar with all the G and M codes, and accordingly I am proceeding further. If you don't know the G codes and M codes, so I suggest please go through the meanings of the G codes and M codes that are available in any of the CNC or SIM textbook. So first line, it suggests square bracket billet x32 z100. So billet is the keyword which will specify the stock of the, or the size of the given stock or the job. That is, the total stock or the total size of the given job is diameter 32 and 100 mm length. So you can see 60 plus 40 is the 100 mm length, and the original stock diameter is 32 mm. Then N010, so N1010 is a sequence number or a line number. G90, it is absolute method of dimensioning. G21, metric method unit system, that is metric unit system. G54, it is zero offset. G00, it is tool rapid traverse. M05, spindle of X32 Z10. So X32 Z10 means the position just along this line, that is 32 mm diameter and 10 mm to the right of this origin, so somewhere here. So this is my position. So I'll just put a dot there so you can just imagine. So this is 32 mm dia. If I take this as a, you can see, I'll take this as a X32 Z10. So this is my safe position. Now I'll do the first operation, that is facing. So first operation is facing. You can see N020, that is second sequence number, G01, that is linear traverse of the tool, M03 spindle on X0, X0. So always remember, in turning, X and Z should be written separately so that we can carry out individual operations, that is turning correctly. If you write X and Z on the single line, it will take taper, that is both the coordinates it will assume, and it will cut in a taper direction accordingly. Hence, you should be very careful while writing X and Z on the same line. So always remember, X and Z should be written on the different lines. So the first operation, as I said, it is a facing operation, and always remember, in CNC program, facing is given by X0, Z0, but always written on the different lines. So G01, it is a linear traverse of the tool with depth of cut, or the cutting is carried out in this particular operation, spindle on M03, X0, Z0. So these two particular lines, that is N20 and N30, will take care the facing operation. Then N40, G00, X32, Z10. So always it is a practice, good practice, to take a tool to some safer position after one operation. So it is G00 means rapid traverse. So after doing this facing operation, what I am doing, I will be bringing the tool to G00, X32, Z10. That means this safe position here somewhere. So always it is a practice to bring the tool to the safer position. Now I'll do the turning operation. So G01, that is linear travel or the linear traverse of the tool. M08 coolant on, M03 spindle on, X30. So from this, that is from this position X32 to, I have brought it to X30, that is 2 mm inside, and Z minus 40. So what will happen? So from this position, that is, as it is absolute mineral dimensioning, it will identify G0 and it will move 40 mm inside. So I have given a depth of cut as 2 mm because from 32 to X30. So I am reducing the diameter of 32 to a 30 for a length of 40 mm. So Z minus 40 indicates the turning length of this particular shaft. So what is happening? So from 32 mm it has gone to 30 and the tool has moved inside for a length of 40 mm. So I have reduced this particular step to a diameter of 30. So in first cut. Then again I'll ask the tool to get to the safer position. So you just notice I have used again G00 and not G01 because during rapid traverse I am not going to cut any material and I'll be saving lot of tool movement timing. So G00, X32, Z10. So it will come to again a safer position somewhere here. Then from 30, that is from diameter 30 to, I'll reduce it to 27. So now again I'll reduce it to 27. So here I need to use G01. So G01 because I need to cut the material. So for cutting the material, you should use G01. Otherwise, if you miss to give this G01 here, what will happen? The software will understand the previous G codes and automatically it will not cut material here. So earlier it was G00. So if you don't give G01 here, it will take G00 and it will proceed further. So now I have to cut the material. So that is why I have used G01 X27. So from 30, that is, I have reduced it to 30. So from 30, again I am reducing it to 27 for a length of 40 mm. So now I have reduced it to 27 mm. Then again I'll get the tool to some safer position that is X32 Z10. Then again I'll do the machining, that is I'll do the turning, that is G01 X25, which is the required diameter. So which is the required diameter. X25. So you can see, where is that? Yeah, X25 G01 Z minus 40. So from 27 to I have done the turning to a 25 mm length, and I have cut for a length of 40 mm, that is turning length. So you can see, so I have reduced the given job to a 25 mm dia, and so my operation is complete because this is the required dimension I should have in my job. So that is why I have completed the required operation. Now I'll ask the tool to get to some safe position, that is G00 X32 Z10. Then I'll make spindle off, that is M09 M05 M30. So this is program end. M05 spindle off, M09 09 coolant off. So this is the first program. So just go through the program, and if you have any difficulties you can write to me anytime. So this is first program. I'll just close this window. Now I'll start with the second program. Sorry, I think in the earlier presentation the video audio was off. So again I'll explain this. So this is the job given. So this is a shaft of diameter 32 and length 90 mm. So you have to do a step turning for a diameter of 25 for a length of 20, and then after that there is a step of 30 mm dia for a length of 10 mm, and after that there is a taper from a diameter of 20 to a diameter of 32 mm for a length of 30 mm. So initial things remain same. So I located the 0 at the left, right extreme face at the center point. So first I'll do the facing operation. So I'll specify the size, that is square bracket billet x32 z90. So you can see 30 plus 30 60 70 20, that is 90 mm, and diameter is 32 mm. So this is the total size given. Then first sequence number, that is first line G90 G71, that is absolute metric. So earlier I had used G21, so you can use G71 also. G0 rapid traverse, X40 Z10, that is some safe position, that is just 5 mm above this and 10 mm to the right from this 00 position. So this is somewhere here. This is my safe position of the tool. Spindle off. Then M06, there is one more new M code, that is M06, that is tool change. So I'll be using tool number 3, that is T03. Then G00 X33Z1. So from this X40 position, I'll just bring tool to just 1 mm above this and 1 mm to the right side. So somewhere here. So I'll ask the tool to come here. Then in the earlier example, I did not specify the spindle speed, so you can specify that spindle speed. So yes, 1000 means speed of the spindle is 1000 rpm. Then feed rate is 50 rpm. Then M07 spindle, coolant on, and M03 spindle on. So first operation facing, already you know this, G01 X0 Z0. So this should be written separately on different lines X and Z. So first facing operation has been done. Then again I'll ask the tool to come to the safe position G00X33Z1. So somewhere here, that is 33 means 1 mm above this, and Z1 means 1 mm right from this 00 position. So somewhere here. Then I'll do step turning of diameter 30 first for a length of 30. You can see G01X30. Okay. So G01X30. So directly I'll be giving from 32 mm to 30. I'll be reducing the diameter for a length of how much? 30. So 20 plus 10. So Z minus 30. So I have done the first step turning operation. Now I'll ask the tool to get to the some safe position. So yeah, I have made a mistake here. G01 I have specified. It should be G00X33Z1. So somewhere here. Now I'll reduce it to diameter of 25 for a length of 20. So this step I'll be doing in this next sequence of operations. So you can see here. So first I'll reduce it to X26, that is G01 X26. So from 30 mm 26 for a length of 20. Then again I'll ask to tool to some safe position G00 X33Z1. So somewhere here. Then I'll give the required dimensions of this particular step dia, that is X25, that is G01 X25, G01 Z minus 20, that is this particular step. Okay, so now my these two operations are completed, or these two steps are machined. Now the remaining operation is this taper. So for carrying out the taper operation, just see here what I'll do. I'll ask, so after performing this, I'll ask tool to get at G01X33. That means somewhere just 1 mm above this. Okay, and Z is minus 30. So I'll ask tool to come here, just 1 mm above this, 30 mm length and 33 mm dia. So somewhere here it will come tool. Then I'll give G01. What is that? Yeah. So I'll give now from this 33 mm dia, I'll ask tool to at x27. So I'll ask tool to come at x27. So what this tool will do? So from this x33 position, it will come to the diameter 27. That is, it will get uh, digged into the material to a diameter of 27 mm, and then I'll specify G01 x32 Z minus 60. That means from this 27 mm dia, it will directly do this taper. That is this particular line it will draw. That is, you can see what is that x32, this diameter. What is the length? 20 plus 10 plus 30, that is 60. So you can see G01 x32 Z minus 60. Then again I'll ask the tool to come to x33 Z minus 30. So again it will come just 1 mm above this and 30 mm uh, to the left of this origin. So somewhere here. Then from this position I'll directly go to 20 mm dia. So you can see x20 and I'll give x32 Z minus 60. That means this end, that is this particular point. So from this x20 it will directly do the taper operation and my entire taper will be created. That is, I'll perform all the required taper operation here by x20, then x32 Z minus 60. So x32 Z minus 60 is nothing but you'll be giving the taper of required dimensions. Then I'll just get the tool to some safe position, G00 x40 Z10 M05, that is spindle off, M09 coolant off, and program end and rebind. So if you see from 27 I have directly given the x20, but in actual practice it is not followed. We cannot give directly depth of 7 mm in one go. Always it should be given in fractions, because otherwise it will uh, damage your tool. So you should be giving the depth of cut very small. But as this is just a simulation, so I am giving more depth of cut and I'll be performing the operations. Okay. So this completes your second exercise. Then I'll go to the third exercise, that is the taper, sorry, the threading operation, how to perform or how to done on the job along with the radius cutting. You can see, so this is the job given. So I'll just zoom it more. This is the job given. So you can see the job stock is 40 plus 30 70, 70 plus 15 is 85 plus 25 110 mm, and this excuse me, this diameter is 32 mm. I think it is missed here. So this diameter you take it as 32 mm. So the job stock is billet x32 Z110. So you can use any case letters. It is not compulsory that you should write the code in uppercase. You can use a smaller case also. So x32 Z110 is the total stock given. Okay, so from that stock we need to do the threading operation for a length of 25 mm. Then there is a step of I think this diameter I have missed, so I'll just check this. What is the diameter? Yeah, it is 20 mm. So this step is 20 mm. So I'll just mark it. So this diameter is 20 mm, and then there is a radius cutting of 30 mm radius. Okay, so these are the operations that I need to perform on this particular job. So you can see I have specified the billet size as X32 Z110. So 32 diameter shaft for of a length of 110 So first line as it is, G90 absolute, G71 metric, G00 that is rapid traverse, X40 Z10 somewhere some safe position here at this particular corner, M05 spindle off. So first you need to check whether the machine is off or no. Then M06 tool change, T01 that is first tool I am going to use. You can use a tool of your choice. There is no compulsion that you should use T01 also. So now I'll ask tool to get at X33. So just 1 above the stock. So 32 is here. 1 above this 33 and 1 to the right side somewhere in at this particular position. Spindle on, that is with 1000 rpm. Yes, 1000. Feed rate 50. So coolant on M07 and M03 spindle on. Then first facing operation G01 X0 Z0. This is facing operation, already familiar with this particular operation. Then save position. So this should be G00, not G01. G00 X33 Z1. So somewhere here 1 above this particular stock tire and 1 to the right. So this is my origin. This particular center line is origin. Now I'll reduce it to first 25 diameter. So G01 X30. So from 32 to 30 I'll be reducing for a length of 25 So you can see X30 minus 25. So this 32 will be reduced to 30 for a length of 25. Then some safe position. So again this should be G01. I have used G01. This should be G00. X33 Z1. So some safe position. Then I'll reduce it to 25 dia because M25 I need to turn this particular step. So X25 Z minus 20 25. So I have created this particular step. Now G00 X33 Z1 M05. So I'll ask tool to come here 1 above and 1 to the right and spindle off. Why I am doing spindle off? Because I need to change the tool for performing this taper, performing this threading operation. So M06 T03 M03. So tool change to tool number 3, then spindle on again. Then G01 X33 Z minus 25. So X33 is here, Z minus 25. So here. So I'll bring tool just 1 above this at this particular point. Then directly reduce it to X20. It is G01 X20. So I'll be cutting this step. And what is the length of this particular step? 25 plus 15 because we are using absolute method of dimensioning 40 So Z minus 20 you can see Z minus 40, that is X20 Z minus 40. So this particular guru has been created. Okay. Now again I'll ask tool to get to X33 Z minus 40. That means just 1 above this, that is here, and 40 So this will understand the tool has to go at X33 Z minus 40. Then I'll ask tool to come at X20. That means at this particular endpoint. So from this point, it will directly come to X20 position because this diameter is 20 So this point is 20, and from this I'll give the radius cutting. So G03 because there are circular interpolation codes G02 and G03. So G03 is anti-clockwise direction. So you can see from this as the starting point, if you just go along this arc, it is in anti-clockwise direction. So that is why G03. If the arc would have been in clockwise direction, then the code would have been used as G02. But it is in anti-clockwise direction, so that is why we are using G03. You can see G03 X32 Z minus 70 R30. That means this point I need to specify, that is end point of the arc. That is, what is the diameter? This diameter is 32. So X32. What is the length? 25 plus 15, that is 40, plus 30 is 70. So you can see minus 70, Z minus 70. Then R30, that is radius cutting. Okay. So this particular line will take care of radius cutting. Then I'll do the threading now. So N190 G00 X35 Z5 M05, that is spindle off, tool change, that is tool number 5 is the threading tool. So this is a safe position. I have asked the tool to come somewhere X35 5 mm. Excuse me. Now the sequence number 1, N200, G01, X32, M03, spindle on, then diameter X32. I'll ask tool to come at X32 position, so somewhere here. Then I'll ask again tool to come to at X25, so it will just come here at this particular point. Then I'll specify the threading cycle, that is G33 is the threading cycle G code. Z minus 25, what is the length of the thread you are giving? 25 mm. And what is the pitch? It is specified as 2 mm, that is into 2 is nothing but 2 mm pitch. And the spindle speed is 500 rpm, because always the thread cutting should be done at a smaller speed, spindle speed. So this will be that is, this particular line will take care of the threading operation. Then already I have performed all the operations. So N230, some safe position, I'll get the tool, that is G00X40Z5, M05, that is spindle off, and M30 program end and rewind. So this completes your third program. Now we'll see how to use the Fanuc Denford software to simulate this particular program. So already I have typed this program in Word file, and and I have saved those Word files as .fnc. Okay, so I'll just stop this.